Before entering the hydraulic bay, you should ensure that the air brake and lift spoilers are closed. The hydraulic bay door is on the right side of the aircraft. When you first look into the hydraulics bay, you need to check for leaks. If the compartment is kept clean, any leaks that might occur will be more obvious. Click on the arrows to check. If there are any leaks, take care not to come in contact with the fluid. The system uses a hydraulic fluid called phosphate ester type 4, also known as Skydrol. This fluid can be harmful to your skin. Each reservoir has a sight glass. This sight glass is used to check that the contents of the reservoirs are in the green sector. The exact level for the yellow system will depend upon whether both accumulators are charged. One is charged, or both are discharged. On top of each reservoir is an air gauge. Before the engines have been started, the air pressure should be at a minimum of 25 psi. There are 5 filters in the hydraulics bay. These are checked to make sure that none of the red filter blocked indicators are showing. The yellow and green system accumulators are pressurized with nitrogen. They are checked to make sure they are both pressurized to a minimum of 1000 psi. The same check should be carried out for the air stairs accumulator if fitted. Click on the arrows to check. Should you find a problem with any of the components you have checked, call an engineer. The park brake can only be operated from the captain's brake pedals with the yellow system selected and the battery switched on. The emergency brake selector switch should be set to normal. The park brake is set by depressing and holding the captain's toe brakes, then pulling the brake handle up. The yellow brake pressure gauge at the captain's instrument panel shows the pressure that is being supplied to the brakes. When the engines are not running, the pressure being supplied is the remaining pressure stored in the brake accumulator. Once the park brake has been set, we continue the cockpit checks by checking the DC pump, AC pump, and the PTU. To check the function of the DC pump, the spring-loaded switch is depressed and held in the on position. The yellow brake pressure gauge, located on the captain's instrument panel, is checked. The pressure should be rising. Then, when the brake accumulator low pressure annunciator on the hydraulic panel goes out, the switch can be released. The AC pump switch has three positions: auto, on, and off. During cockpit checks, the pump is tested in both auto and on position. To begin the check, the switch is set to auto. In this position, the pump would operate automatically if the output of either engine-driven pump is below 1,500 psi. It will continue to operate until switched off. With the switch in the auto position, yellow pressure will start to rise. Once the yellow system pressure is rising, the switch can be moved to the on position. In this position, the pump will run continuously until set to off. At about 1,750 psi, the yellow system low pressure annunciator will go out. If the AC pump is running, either in the on or the auto position, yellow hydraulic pressure is delivered to all the yellow system services. When yellow system pressure has stabilized at 3,100 psi, we can turn on the PTU. The PTU on-off switch operates an isolation valve, which then selected on brings the PTU into the system. Do it. The PTU valve annunciator is lit when the valve is not in the position selected. With the PTU switch on, green pressure will rise. At 1,750 psi, the green system low pressure annunciator will go out. Do it. The pressure will stabilize at about 2,600 psi. The hydraulic warning on the central warning panel will also go out, as we now have pressure in both yellow and green hydraulic systems. With the AC pump running to give a yellow system pressure of 3,100 psi and the PTU switched on, all the hydraulically operated surfaces except the standby generator are available for use. To finish the cockpit checks, the PTU is switched off. Then the AC pump is switched off. Do it. The PTU valve and AC pump fail lights are checked to make sure they have gone out. The AC pump fail light will come on in the following circumstances. The AC pump is turned on and it fails to operate, or its output pressure is below 1,500 psi. The AC pump is set to auto and the pump does not operate when either EDP is delivering less than 1,500 psi. The AC pump is turned off and it continues to run. After the engines have been started, the engine-driven pumps, which are now running, are connected to the system. The two valve annunciators will light as long as the valve is not in position selected. Do it. An inbuilt delay prevents the MWS giving false warnings. At this point, the low-pressure annunciators on the hydraulics panel should also be out. The system pressure should be stabilized at 3,100 psi. We now take a look at the schematic view. We can see that with both EDPs on, delivering a pressure of 3,100 psi, all the hydraulically operated services are available for use. To complete the after-start checks, the AC pump switch is set to auto and the PTU is switched on. Do it. It is important that the AC pump is not switched on before the low-pressure annunciators are out, because the AC pump would operate and remain on. A final check is needed to make sure that the AC pump fail and PTU valve annunciators are out. The hydraulic warning on the central warning panel should also be out. This is what the hydraulic panel would look like during a normal flight. All standby facilities are now armed and available if required. During shutdown, check that the hydraulic systems are switched off in the reverse sequence. We put the PTU off first, then the AC pump. If the pressure drops when the PTU or AC pump is switched off, this indicates that an engine-driven pump has failed in flight. The EDP valve switches must be selected off last. If either EDP fails, there is no indication to show that the pump is lost. However, for modified aircraft, a white annunciator AC pump on will illuminate on the central status panel. If an EDP failure occurs, appropriate backups will operate and the system will continue to work. The AC pump will ensure that the pressure is supplied to the yellow system. With a number 3 EDP failure, there will be a reduction in green system pressure from 3,100 psi to 2,600 psi because of PTU operation. Loss of a pump would not lead to loss of a system. This is more likely to be caused by loss of fluid. The initial indication would be low quantity, followed by low pressure annunciators coming on. Loss of fluid in the green system. Here is a fluid loss in the green system. The fluid loss needs to be stopped as soon as possible by removing pressure from the system. To remove system pressure, first turn off the engine-driven pump 3, then turn off the PTU.